All right, welcome back to Mr. P Helps with Algebra. This is Unit 4, Topic 2, Lesson 4. And we're going to be converting standard form into vertex form by doing something that's called completing the square. All right, so starting off with the warm-up, we got linear equations here. We're going to find the x and the y intercepts. 20 divided by 5 is 4, so that has an x-intercept of 4, which is right there. 20 divided by negative 10 is negative 2, so there's 2 points on the line, which means I can now connect them. Negative, okay, what do we got here? So 2 divided by, the x and the y's are on the opposite sides. So I would divide everything by 2 in this case. So that'd be y equals 3x minus 9. And then I can just simply graph the y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it didn't really fit. And then go up 3, right 1, up 3, right 1, because that is the rate of change. And there's your equation. Not very straight, though. Y equals negative 6x plus 6, so 1, 2, 3, 4, 5, 6. This works out a little bit better. And then it's down 6 for every right 1, because that's the slope, negative 6. 1, 2, 3, 4, 5, 6, right 1. And you've got an equation that goes down like such. All right, so let's get into it. So first we're going to talk about vertex form. So we're going to break it down by its key features like we've done in previous videos. The vertex of this equation right here would be at 3, 4. Remember, whatever's inside the parentheses is always the opposite. It has an a of 1, which means it's opening upwards, which means it has a minimum value because it goes up infinitely. It's definitely going up, as I just mentioned. The translation means it is going right 3 and up 4. And you know that because of h and k. H means right 3, and this means up 4. The line of symmetry is going to be x equals 3. When is that increasing? So it's decreasing when x is less than 3. So it's until it gets to 3, and then it's going to go back up, which means it's increasing when x is greater than 3. Okay, down here, so we've got a new equation. It looks like this. That's standard form. It says draw a perfect square using the algebra tiles. So like in the last video, I'm going to take one flat, 1x squared. And I've got 6 longs, and they happen to be red ones because they're negatives. 1, 2, 3. If I put 3 on each side, and then you will notice that it's going to leave this square right here. In order to complete that square, it's going to take 9 little units to complete that square like such. Okay, so 9 little units. So the 9 units go there. The flat goes there, and we've got the longs right there. There's 6 of them, so that does complete the square. Now, that makes the square exactly x minus 3 times x minus 3. So this is what we call a perfect square, because it is a perfect square. It's not a rectangle. It's an x minus 3 squared. All right, so that was the answer to the next question, I believe. So this is x minus 3 squared. Now, if I want to write that in vertex of the parabola, so what is the vertex of the parabola? That would be at 3, 0. Because this is vertex form. Remember that this is always the opposite of what you would expect. Plus, there's really a 0k here at the end. So 1, 2, 3 is that. A is 1, which means each term next to it, previous and next, are both 1 above. So there's my simple graph. Pretty easy. It's a translation of x squared being moved 3 to the right. That's it. That's the description. That's all you need to know. That's all that's happened. All right, so now we've got standard form again. And we're asking ourselves, well, does this fit the model of being a perfect square like the last one? If I take 1 flat and I take 4 longs and I put 2 on each side, I'm going to need 4 units to complete that square, but I've only got 2. There's no way to complete that square. Even if I do the 1 flat here and 1 on one side and 3 on the other, I'm still going to need 3 units to fill that spot, and that's not what I have. Or if I say, some of you might be thinking, what if I put all 4 of them on one side? Then I would need no units in order to complete that rectangle. So therefore, this is not what I need for a perfect square. It's not even what I need for to make any kind of rectangle whatsoever. So that does not work. So what do I need here? What I need here is 2 more units to fill this square. So if I can make an x plus 2 square, you will notice that I put my 2 units that I have right here, and I'm missing 2 more units that go right there. So to make up for it, I'm going to subtract the 2 units that I didn't have to make up for these 2 units right there. And now notice what you got. You've got we just turned standard form into vertex form, which was the objective for this lesson, just that easily. So is the equation you have written equivalent to the original equation? Yes, it is. It's equivalent because I've got an x plus 2 square minus the 2 blocks that I didn't have to begin with. And then I could simply graph that by going left 2, down 2, right there. A is 1, which means it's right above, and boom, there is your parabola. So that is a translation of left 2 and down 2, and it's just like x squared because there's 1x squared. A is 1. All right, homework. So what does it take in order to complete the square? So what you probably have noticed, whenever you have standard form, you've got ax squared plus bx plus c. What you might have noticed is in order to find c, all you have to do is divide b by 2 and multiply it by itself. Or if you're given c and you're trying to find b, then what you do is you do the square root of c and multiply it by 2. Because think about your area formula. So when you're making a perfect square, you're going to have an equal amount of longs on each side. So when you do the square root of this, that tells you how many is on one side, but you have to multiply by 2 because there's 2 sides. So half of negative 10 is negative 5. Multiply it by itself makes positive 25. Half of that is 6, means this has got to be 36. Now, half of this is 7.5. Sorry, I don't have a calculator on me. I'm going to have to do this by hand. That's going to give me 37, 35. If I make a mistake here, just let me know in the comment section. 49 plus 3 more makes 52. Oh, well, 42, sorry. Let me see if I did that. No, it was 52. So 7 times 7 is 49 plus 3 more makes 52. 7 and 5 makes 12. 3, 4, 5, 6. All right, so it looks like it's going to be 56 and 25 hundredths. All right, so half of 18 is 9 times itself is 81. Half of negative 11. Oh, it looks like we've got another decimal here, so that's 5.5 times itself. Okay, let's see, 25, 25, 27, 25, once again there, 27 again. I'm probably going to not be able to read my handwriting here, so 7 plus 5 makes 12. I think that was a 7, 8, 9, 10, so 2, so it looks like 30.25. I probably messed up around somewhere the way because I can't see my own handwriting. This one, so it's half of 1/2 is 1/4, and 1/4 times itself, that's actually pretty easy. 1/4 times itself is 1/16. Okay, so now remember what I said earlier, and I'm going to erase all this because this work's getting in my way anyway, is whenever you're given the c and trying to find the b, do the square root of the c and then multiply it by 2. So square root of 16 is 4 times 2 means this is 8. So that works out. So if you got 4 on each side, 4 of the longs on each side, 4 times 4 would make 16. That's 11, double it, and you get 22. 625 is, I believe that's 25 squared, so 25 times itself is 50. 225 is, oh, I'm going to use that calculator, I guess. Well, let me look at this one. So now we've got leading coefficients. So this one is 9. So that'd be 3 times 2 would be 6. Now we've got leading coefficients. So we got a 25 here, and we've got a 49 here. So this is really going to be 5x plus 7 squared. And now when you do 5x plus 7 squared, 5 times 7 makes 35. Double that, and you get 70. So that actually turns into 70. This is going to be a perfect square of 3x plus square root of 225. Can't think what that might be off the top of my head. So let's see, calculator. Is that 15 times 15? Yep, that's what I thought it was. So 15. So 15, so that's going to be plus 15. 3 times 15 makes 45. Double it, and you get 90. There we go. With or without a calculator, I was able to do it. Please give it a like if I helped you learn something about completing the square, changing standard form to vertex form. And please tell people to subscribe if they haven't done so already. Thanks for watching. Have a great day.